All right, this is an optional video. If you are wondering where these two formulas come from, I'm going to provide a justification for it. So essentially, I will be deriving these formulas, okay? So we are going into this assuming that we are dealing with an arithmetic sequence that has first term A1 and common difference D, and our goal is to provide a formula for Sn, the nth partial sum. So we're just adding up the first n terms of our arithmetic sequence. Okay, so we're coming up with these. Okay, all right. So to begin, okay, I'm just gonna write out what I'm doing. Okay, I'm trying to come up with Sn. That means I'm adding the first n many terms of my sequence. Okay, so I'm at A1 plus A2 plus A3 plus all the way to AN minus 1. That's the term that comes before AN. And then we have AN. That's the last term we add. Okay? All right. So now what I'm going to do is use some of my previous work. If you remember early in this section on page 2, we came up with a formula for the nth term of an arithmetic sequence. Okay, we came up with this formula right here in the blank. Okay, and to do that, we did this little exercise where we started writing out the first 6 terms of the sequence, and we tried to make each one in terms of A1 and D. So we know we had to start somewhere, so we just called A1 A1, and then we said A2 is the same thing as A1 plus D, and then we said A3 is A1 plus 2D, and so on. Okay, so hopefully you remember doing that. So I'm going to use that information here. Okay, so in my next step, okay, I'm going to leave A1 as A1, but then I know that A2 is the same thing as A1 plus D. Okay, and then in my next step, okay, I know that A3 is the same thing as A1 plus 2D. Okay, so these guys are the same quantity. Okay, and then I keep going. Okay, I'm going to jump to the last term here. Okay, we know that AN is the same thing as A1 plus n minus 1 times D. That was the formula we came up with. So if you apply this to the term that came before it, okay, AN minus 1 is the same thing as the first term plus n minus 2 times D. Okay, so these two guys are the same quantity. Okay, so you can see how this is playing out. Okay, we're just getting creative, rewriting the terms in the sequence in the series just in another way. Okay, all right, so I am going to box this. Okay, we're going to come back to this. We're going to take a little break. Okay, we will use this information a little later. All right, so what I'm going to do now, okay, is do basically the same thing, but in a different way. Okay, so I'm still going to write out the terms of my sequence like I did. When I started, I did A1 plus A2 plus A3 all the way up to AN. Okay, but I'm going to reverse the order. Okay, think about it this way. If I'm adding just 3 numbers, if I do 1, 2, and 3, I'm going to get 7. Or sorry, I'm going to get 6. But if I reverse the order, 3 plus 2 plus 1, that still gives me 6. Okay, so reversing the order, doesn't change anything. Okay, so this time I'm going to go down here and I'm going to write my sum in reverse. So I'm going to start with the last term and then add the term that came before it and then add the term that comes before that one. All the way down to the end, my last 2 terms will be A2 and A1 if I'm summing. Okay, and then we're going to get creative again. We're going to try to rewrite each of these guys in a different way. Okay, so I'm going to come up here. Okay, I'm going to leave AN as AN. And then how do you get AN minus 1? How do you get the term that came before AN? Well, you take AN and you subtract the common difference. Okay, so this is the same thing as this. Okay, to get the term that comes before AN, to get AN minus 1, you take AN and you take away the common difference. Okay, and then what you're going to do to get this guy, okay, to get AN minus 2, the term that comes before an minus 1. Well, you're going to take an and take away 2d. Okay, so these two guys match. Okay, and then you keep doing this. Okay, so we're going to have these terms in the middle, so plus dot dot dot. Hang on, let me change my color here. So we'll have plus dot dot dot. Okay, and it'll get a little tricky when we get down here. Okay, let's deal with a1 first. Okay, how do you get a1? Well, if you started with an, you'd have to take away n minus 1 times d. Okay, you can kind of write that out with a specific example and check that out. Okay, but that's how this is going to work. Okay, all right, and so then that means the term that came before it, or let me color code these two match. These two guys match. Okay, and then another way that you could write a2, okay, another way to write a2 would be an minus n minus 2d. Okay, so this is another creative box that I've come up with, just writing the terms in an alternate fashion. Okay, both of the things in the box represent Sn, okay, the nth partial sum here. Okay, so what I'm going to do is add these guys up. Okay, so if I add, I'm just going to add across the columns. Okay, so for example, I'm going to add these two guys together. Sn plus Sn is going to give us 2Sn. Okay, and then I'm going to move over and I'm going to add these guys. Okay, that's going to be a1 plus an. Whoops. Okay, so this is going to equal a1 plus an. Okay, and I'm going to put this in parentheses. This came from the first piece. All right, so then I'm going to move over and do it again. Okay, I'm going to add the stuff in the next column. Okay, so these guys. Okay, look at what happens here. You're going to get a1 plus d minus d, so the d's cancel, so you're going to be left with a1 plus an. Okay, so I'm going to get another a1 plus an. Okay, and then I do it again. Move over to the next column. Okay, add these guys. Okay, 2d is going to cancel with negative 2d. I'm left with a1 plus an. Okay, so here we go, another one. Okay, and then we skip our terms. Okay, we come back to the end. Okay, at the very end, let's look at these guys. Okay, so now we're adding the last columns up. Okay, you've got an n minus 1 times d, a positive one, canceling with the negative one down here. You're left with, guess what? a1 plus an. Okay, so all that other mumbo jumbo has gone away. Okay, how many a1s plus an's do we have? Well, we had it for the first term. Okay, we had it for, sorry, the first term's over here. What am I thinking? Okay, so we had it for the first term, we had it for the second term, the third term, all the way to the nth term. Okay, so we have this n many times. Okay, so that tells us that 2 times the nth partial sum is going to be n times the quantity a1 plus an. Okay, and then if you want to solve for the nth partial sum, you just need to divide off this 2 in front. Okay, so that's going to give you n divided by 2 times the quantity a1 plus an. Okay, so that's where this first formula is coming from. Okay, and then now that you know this one, it's really easy to get this one. Okay, all we're going to do here, okay, to go from one to the next, we know that an is the same thing as a1 plus n minus 1 times d. Okay, we're going to make that replacement, and then you're going to see that the other equation will appear. Okay, so here I'll do it in a different color. Sn is going to be n over 2 times a1 plus n minus 1 times d. Okay, so then you get that Sn is equal to n over 2. You end up with 2a1s plus n minus 1 times d. And that is the second formula. Okay, so that's where these two particular formulas come from. Okay, you really have to get creative sometimes when you're deriving things.